are using with medical purpose: reproductive cloning and therapeutic cloning. Reproductive and therapeutic cloning. Reproductive and therapeutic. Reproductive, you are writing what is this. I put it intentionally with the large letters to make you understand it easily. Reproductive cloning is technology used to generate animal that has the same nuclear DNA, what is important here, as another currently or previously existing animal. It means that we theoretically can take DNA from some extinct species, for example, and create them de novo, but just in theory. But in this definition, this approach is written. Reproductive cloning, technology used to generate an animal that has the same nuclear DNA as another currently or previously existing animal. And then again, short description, and then movie. And you will be relaxed. But this must be written. Next. Cloning, this is what you should write. And then we will switch and move it. Cloning involves the removal of nucleus from one cell and its placement into an unfertilized egg cell whose nucleus has either been deactivated or removed. How does it look like? We will see now. Cloning involves the removal of nucleus from one cell and its placement in unfertilized egg cell whose nucleus has either been deactivated or removed. For example, we need to clone elite dairy cows. Donor cells grow in culture. We took the cell of usually taken mammary gland for that, and donor cells grow in culture from this mammary gland, for example. And this is cow egg from ovary. And then we remove from this ovary, we remove nucleus, pronucleus, which is unfertilized, and insert the nucleus of the cell of mammary gland of this cow, and what would we have in this case? If this pronucleus unfertilized is removed from the egg cell, and the cell and the nucleus of the cell of mammary gland is inserted, what would we have as a result in here? We will have zygote. Yes, Mia, Anastasia, this is right. Zygote, because here was a number of chromosomes, and in mammary gland there are already how many chromosomes? 2 numbers, of course. And we have here now an zygote. Zygote start to develop, and at the stage of blastocyst, it's inserted into the foster mother, and this mother, after 9 months, deliver the calf, genetically identical to the source, to this elite dairy cow. Is it the same as this cow?
Yes.
Just to some extent. Is it of the same size? No, it is small. Is it of the same age?
No.
Maybe yes, because we took nucleus of the cow of 5 years old, for example. And from the beginning, this cow is 5 years old, but it is small. So there are some peculiarities. And how does it work? Probably if it will be possible, we will see in this video. If it starts to work, yesterday it worked.
Show us the nuclear transfer we'd seen before, but now we're going to see it as an example where a skin cell nucleus is going to be used to make an embryonic stem cell. So the egg cell has the nucleus removed. The nucleus from a skin cell is then injected into that egg. That egg, you'll remember, can then initiate development by dividing, making a blastocyst. Here's this important reprogramming phenomena going on, the details of which are still unknown.
And you see just what we have seen
The cell is now
in the
beginning
picture,
to
not
divide,
in the movie.
continuing to divide to make a blastocyst with an inner cell mass. And then it's from the inner cell mass in that blastocyst that an embryonic stem cell can be derived.
Yes, we are speaking now about the possibility to obtain some stem cells from such embryo, but also this embryo can be put into the foster mother. This procedure, after a few divisions, the artificial embryo is placed into uterus, where it is allowed to develop into fetus that is genetically identical to the donor of the original nucleus. If we want to clone this guy, and it gives us this nuclear DNA, then we have an embryo, and this embryo is not exactly, but almost the same as this one. We have in the cytoplasm some structures which consist their own DNA. What are they? We have nuclear DNA and we have cytoplasmic DNA. Where is it? In the mitochondria. Are mitochondria of this woman replaced? No, just nucleus. And we took nucleus of this guy, put it here, but cytoplasmic heredity is of this woman, of this mother, which was taken to deliver this baby. So this baby is not, and is the personality of this baby, intelligence, the individual characteristics are the same of this guy.
Yes, let's see. So the
How?
mother.
How?
Mother.
He is or she is very small and she should be bred well, and it will take some time, and it will be brought in the conditions which are 20 years, for example, after this guy was born. They will be studying different universities with different teachers, blah, blah, blah. Would it be the same personality as it is?
No.
No. And the difference in, obvious difference in age is 20 years. It's down from the cell, which is not very good, but the difference is significant. Reproductive cloning, dog is a sheep. You know that. The first, we will not stay at this slide for much time, but you know that the first successful cloned animal was Dory. In February 1997, it was cloned, and however, Dolly died shortly after that, and all of us must realize what I have just told you, that clones are not truly. Any animal created using nuclear transfer technology is not truly identical clone of the donor animal. Please write it down. Because this is important, and you should understand and explain me on the practical why is it like this. Why all of them cheat to us while showing us movies that clone is done and they too now running and doing the same obligations, the same things and so on. And they have the same mentality? No, anyway. It's not possible at the modern state of development of the cloning, at least. Any animal created using nuclear transfer technology is not truly an identical clone of donor animal. Which are only truly clones? How can we get natural clones? But anyway, they will have also different personality. Only clones chromosomal or nuclear DNA, this is explanation. We will not write it, only chromosomal or nuclear DNA is the same as the donor. Some of the clone's genetic material come from mitochondria, is the cytoplasm of the enucleated cell. That's why it is not the same. Another, what we have spoken about, is health aspects. Success rate of cloning is low. Dolly was born after 277 eggs were used to create 29 embryos, which only produces 3 lambs at birth, and only 1 is lived Dolly. So efficiency is less than 1%. The next 90,000 attempts produce one third of them died young. 70 calves produced from 9,000 attempts. Paris, Texas, this is the horse or calf, was created after 400 attempts. Why is it? Errors of incompleteness in the reprogramming process cause the high rates of death, deformity, and disability observed among animal clones. Because we take old nucleus, which work in the mammary gland, for example, and we ask this nucleus or force this nucleus to become the whole body. It says, I'm sorry, I'm mammary gland cell. What do you want from me? And, of course, if it is reprogrammed back again to become an embryo, we face and we can observe mistakes. That's why clones usually weaker than the naturally created organisms. Human cloning. You are right in this. What is this? Human cloning is the creation of genetically identical copy of existing or previously existing human by growing cloned tissues from that individual. This is the creation of genetically identical copy of existing or previously existing human by growing cloned tissues from that individual. Creation of genetically identical copy of existing or previously existing humans by growing cloned tissues from that individual. And you know that we face here different ethical considerations. With farming of organs from clones. This is one of the most ethically questionable problem. If you produce one clone, take cells from me to produce cells for me intentionally, how you can kill this small child just to get some tissues for my treatment, for example? This is ethical question. And also why we need to initiate young, new human or do it intentionally to save life to another. But however, if to do so, the lifespan of humans, life expectancy can be increased by 50 years. This is on the other hand. Unfortunately, or for luck, anyway, it is approach which develops. And there is no official data about human cloning, because in many countries this cloning is forbidden, including Ukraine. We have also some prohibition, some law which prohibits that. And somatic cell nuclear transfer technique is used to create the human embryos now. For example, and you know that previous year it was done, and the newborn child has 3 parents, again by using nuclear transfer. Healthy nuclear DNA removed from patient egg cell, leaving the half-faulty mitochondrial DNA. Women and mitochondria are important source of energy for our body. If mitochondria are impaired, women can have liver disease, some brain disease, and lack of energy. And in this case, we take nucleus from this woman, replace it into the cell of donor, of healthy woman, and then fertilize it by sperm of the father of the husband of this first and the child has 3 parents, like this. This is the world's first baby born with new 3-parent technique. It was done by United States scientists, but in Mexico, while it is forbidden to do such genetic experiments in United States. To our proud, to Ukrainian proud, the second child was born in Ukraine in January of current year. We have the same successful attempt, and the girl was born in Ukraine also, while using this technique. However, the only difference was that in Ukraine, nuclear transfer was made for egg which had been fertilized. So, for fertilized egg, they made the replacement. The egg was fertilized before, as far as I understand, and then this fertilized nucleus was removed, and in this cytoplasm they intervened a nucleus and sperm and fertilized this nucleus again. Mother 1, donor woman with egg with healthy mitochondria, and you see that donor egg with mother's nucleus is fertilized with the sperm from father. But mother nucleus is taken again. Donor's mitochondria, donor envelope, let's say like this, and sperm from father. Baby is born with 3 biological parents. Mitochondria from one mother, nucleus from truly mother, who will be responsible for pregnancy also, and sperm from biological father. That's why this genetic approach is already used for us. Therapeutic cloning. Write down. We have a few minutes. I was not overloaded. We have just 3 minutes and 5 slides. So I think we will proceed with that. Therapeutic cloning. The egg is placed into petri dish where it develops into embryonic stem cells which have shown potential for treating several ailments. This is the therapeutic cloning, when we don't use the same techniques for reproduction but for obtaining of the stem cells, which then use it for treatment. We will speak more about on practical class, during the practical class. And next is 2 types of stem cells, also mandatory to write down. 2 types of stem cells: adult stem cells, which are found in our body, which already exist, and they are responsible for renewal of our body, and embryonic stem cells, which are created intentionally. While using these techniques which we have seen before. Nuclear somatic cell nuclear transfer, for example. Exactly this one is used. Embryonic stem cells and adult stem cells. Adult in our body and embryonic in the body of created de novo, intentionally. You have to write just adult stem cells and embryonic stem cells. And ways of embryonic stem cells obtaining. They can be obtained de novo from 2 people, donor and donor fertilization, and then transferred to the patient. But better, as you, I'm sure you will agree with me, to take nucleus from this guy, from this donor, put into the egg of some woman, and then produce the cells which are almost the same as a patient tissues. There are 2 ways to get the embryonic stem cells. Just take any, for example, people, any donors, and create the stem cells, all exactly perform the nuclear transfer, and take nucleus of this guy and put it into the egg cell of this woman and receive an embryo which is similar with their characteristics with these patient tissues. Embryonic and adult stem cells have both are promising, but have different. Embryonic stem cells are pluripotent, while adult stem cells limited to differentiating into different cell types. Adult stem cells rarer in nature tissues, but embryonic are promising. And this is the last slide of our lecture, promise of stem cell research. As you can see, they can be used for tissues, cells for transplantation, and for healing of different tissues. And the most interesting here is the question, because we don't know the next approach in which it can be used, and this is your turn to describe, to deliver, to bring this approach alive when you will be good specialists. Thanks for attention. You see kangaroo with the rhinoceros in here. Genetically modified animals everywhere.